Hello everyone. In this video, I'll talk about section 10.3 angle subtended by a chord at a point. Now, supposing I have a circle, let's say I have this circle with me, and let's say the center is O, okay, and let's say I have a chord here. I'll name this chord XY, any random chord you can draw here, and let's say I have a point here which is M, let's say. Now, what do you mean by angle subtended by this chord XY at the point M? So, what I will do is I will join the endpoints of the chord XY to the point M this way, and I will join the point Y also to this point M this way. So, the angle that is formed by joining the endpoints of the chord XY at the point M is called the angle subtended by the chord XY at the point A. Okay, I repeat, angle subtended by the chord XY. So I can write here angle subtended by the chord XY at the point M is which one now? Angle XMY or YMX also you can call it. Angle XMY. Now instead of joining the endpoints of the chord XY to M, if I join them at the point O, that is the center of the circle, then this angle will be called as angle subtended by XY at the origin. Okay, so this is the meaning of angle subtended by a chord at a point. So that point may be on the circle or it may be inside the circle like the center. Now I'll come to this example. I have a figure here. State the angle subtended by the chord AB at O. That is the origin. So what is the name of this angle? Angle AOB. So answer to this will be angle AOB. Which is the angle subtended by AB at the point P? The point P is here on top. So the angle will be APB. Angle APB. And same way, angle subtended by the chord AB at the point R will be ARB, which I am marking right now. Angle ARB. Okay. Now, knowing this, we'll jump to theorem 10.1. So, what this theorem says is equal chords of a circle subtend equal angles at the center. So, what this means is, supposing you have a circle here and you have two chords which are equal in length. So, let's say this is one chord and let me say this is another chord. Okay. So, I will take a circle whose center, let's say, is O. So, what I'll do here is I'll draw a circle with center O. And then I will draw two chords, let's say AB and CD, which are equal. So this chord is equal to this chord. Okay. So let AB and CD be equal chords of this circle. So it's given that AB is equal to CD. Now what I have to prove is what this statement says is the angle subtended by these two equal chords at the center, the angles are also equal. That means the angle subtended by AB at the center O is this, and angle subtended by CD at O is this. So these are the angles subtended by these two chords. So if the chords are equal, then the angle subtended by them will also be equal. So you have to prove that this angle is equal to this angle. That is what you are supposed to prove ultimately. Okay. So here what I'll have to do is I'll have to join AO, BO, CO and DO in this manner. So we have to prove that, we have to show that angle AOB is same as angle CO. Okay, so how we'll do this is using the concept from term 1, chapter triangles. So I will have to consider both the triangles AOB and COD. So in triangle AOB and triangle COD, we have to show that both the triangles are congruent. So first you can see that AO is equal to CO. Why are these equal? Because they are radii of the same circle. So they are equal, right? Also AB is equal to CD, that's given. Okay, that is already given. AB is equal to CD is given. And the third point is BO is equal to DO. Again, these are radii of the same circle. So by SSS congruence rule, these two triangles would be congruent. Therefore, triangle AOB is congruent to triangle COD by SSS congruence rule. And therefore, by CPCT, these two angles will be equal, and that is what we had to prove. Therefore, angle AOB is same as angle COD, that is by congruent parts of congruent triangles. Hence, we have proved that angles subtended by the equal chords at the center are also equal. Okay, I hope the proof is clear. Now, the converse of this will be theorem 10.1. I have it here. Now, it is given to you that if the angles subtended by two chords at the center of a circle are equal, then the chords are equal. So here what is given is, one circle is given. One second. Here a circle is given and there are two chords. You do not know whether the chords are equal or not. Okay, so two chords I have here and you don't know whether the chords are equal or not equal. You have no idea about it. And they subtend equal angle at the center. Let's say this is the center. Okay, just a rough picture I have drawn. So this is the center O. Let's say this is A, this is B again, this is C and this is D. So it is already given to you that these angles are equal. Angles subtended by the chords at the center are equal. So again, we'll have to draw a circle with center O. If you see, this is exactly the opposite of the previous theorem. Okay. Let AB and CD be two chords. Now you do not know whether they are equal or not. Just two chords are given to you. And it is also given that they subtend equal angles at the center. So it's given that angle AOB is equal to angle COD. So that is given. And we need to prove that the chords are equal. That is AB is equal to C. So again in the same way we'll have to consider both the triangles, show that they are congruent, and by CPCT the chords would be equal. So in triangle AOB and triangle COD, Okay, again AO is equal to CO, radii of the same circle. Then the angle, if you see, the angles are equal, AOB, that's given. Because this is already given that they subtend equal angles at the center, and BO is also equal to DO. This is again the radii of the same circle. So now you can easily see that by SAS congruence rule, these two triangles are congruent. Triangle ABOB is congruent to triangle COD by SAS congruence rule. Okay, and because they are equal, the corresponding paths also will be equal. So AB is equal to CD, and therefore chords are equal. So that's what you had to prove. So in the previous one, we assumed that the chords are equal, and we showed that they subtend equal angles at the center. And this one says if two chords subtend equal angles at the center, then the chords are also equal. Okay, I hope the explanation is clear enough. Thank you.